Welcome to this video. In this video we are going to discuss about the large sample type 2, test the significance between means. Okay, in this topic first we want to determine the two samples have been drawn from same population or not. Okay, so we are using test the significance between two means. Type 2, test of significance of difference of means. Here we consider two samples of sizes N1 and N2 taken from two different populations with population means mu1 and mu2, and the corresponding standard deviations are sigma 1 and sigma 2. These two samples are drawn from the population. Let x1 and x2 be the sample means, s1 and s2 be the corresponding standard deviation. First we want to formulate the null hypothesis and alternative hypothesis. H0 is mu1 is equal to mu2, that is two means are equal, and H1 alternative hypothesis are there is not equal, mu1 is not equal to mu2. Here the test statistic Z is defined by x1 bar minus x2 bar divided by standard error into x1 bar minus x2 bar, that is x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square by n2. Okay, that is comes under the normal distribution of 0, 1 mu1 sigma. Next, choosing the level of significance, that may be 5% level or 1% level are used here. Next, we compare the calculated value of Z with our tablet value of Z alpha. If calculated value is less than the tabulated value means we accept H0, otherwise H0 will be rejected. Okay, this is the way of finding the difference between two means under large samples. Next, note, first point, if the samples are drawn from the same population with standard deviation sigma, we have to draw two samples from the same population. The corresponding standard deviation is denoted simply sigma. The test statistic is Z equal to x1 bar minus x2 bar divided by sigma into square root of 1 by n1 plus 1 by n2. Here sigma is common for both sample, that is both standard deviations are drawn from single population. This is same population where sigma is known. If sigma is unknown means we can use the sample standard deviation, that is S1 and S2. That is our second point. Instead of population standard deviation, we can use sample standard deviation S1 and S2 is given. Then the test statistics can be written as Z is equal to x1 bar minus x2 bar divided by square root of S1 square by n1 plus S2 square by n2. Here S1 and S2 are the sample standard deviation. If sigma is unknown means we can use this formula to test the statistic. Now we are going to discuss some problem based on large sample difference between two means. The means of two simple large samples of 1000 and 2000 members are 67.5 inches and 68 inches respectively. Here n value is greater than or equal to 30, therefore this problem comes under the large sample. Here n1 is given, sample size of first one is n1, that is 1000, sample size of second one is n2, that is 2000. Here n greater than or equal to 30, therefore this comes under the large sample. Sample size n1 is equal to 1000 and sample size for the second one n2 is 2000, and the corresponding means of the two samples are 67.5 inches, another one 68.68 inches respectively. that is x1 bar sample mean 67.5 and x2 bar for the second sample mean 68. Can the samples be regarded as drawn from same population? The same population means we know sigma. Population standard deviation is denoted by the letter sigma. Here the standard deviation sigma is equal to 2.5 inches. Okay, this is drawn from same population. For only common standard deviation for both samples we have 2.5. Sigma is 2.5 and we want to test the level of significance at 5% level. Okay, first we set up the null hypothesis and alternative hypothesis. Formulate null hypothesis H0 and alternative hypothesis H1. Here we assume H0 is there is no significant difference between the sample mean. That is mu1 is equal to mu2, that is the samples are drawn from the same population. Okay, we assume the samples are drawn from the same population, that is mu1 is equal to mu2. Next we set up alternative hypothesis, that is H1, which is unequal. H1, that is mu1 is not equal to mu2, that is the samples are not drawn from the same population, that is the samples are not drawn from the same population. Next step, we choose the level of significance. In the question itself, we have 5% level of significance, that is alpha is equal to 5% level of significance we applied here. Alpha is equal to 5% level of significance. Next, to find the test statistic, is it equal to, we know the formula for that, x1 bar minus x2 bar divided by, here population standard deviation drawn from same population, that is sigma is common, but remaining 1 by n1 plus 1 by n2. Okay, now you can replace the form values. 67.5 minus 68 divided by sigma is 2.5 into square root of 1 divided by 1000 plus 1 divided by 2000. Simplifying this, we get the answer minus 1. We get the answer by using calculator. We simplify this, we get the answer 5.164. That is modulus z value is 5.164. That is our calculated z value. Calculated value of z is 5.164. Next, we can choose the tabulated value of modulus of z alpha. For percentage level is 1.96 at 5% level of significance. Now comparing these two, that is calculated value is greater than tabulated value z alpha. that is 5.164 is greater than 1.96. Okay, now we draw the conclusion for this. If calculated value is greater than the tabulated value means we reject H naught at 5% level of significance. Therefore, our conclusion is accept H1, that is the samples are not drawn from the same population. Next question. Samples of students were drawn from 2 universities and from the weights in kilogram. The means and standard deviations are calculated. That can be given in the form of tabular column. Test the significance of the difference between the means of 2 samples. Here our sample size is denoted by the letter N1 and N2. Sample mean is denoted by x1 bar and sample mean of second is x2 bar. Standard deviation of sample size is given. Standard deviation of sample is given, that is S1, another one is S2. Here sigma is not given. Instead of that, sample standard deviations are given, that is S1 and S2. Here we assume the level of significance, that is level of significance alpha is equal to 5% level. The level of significance is not mentioned in the question means we assume obviously alpha is equal to 5% level. If it is mentioned mean we can apply that level of significance. First set up the null hypothesis, that is H naught. Here we assume null hypothesis is there is no significant difference between the means, that is x1 bar is equal to x2 bar, that is there is no significant difference between Next we set up alternative hypothesis. x1 bar is not equal to x2 bar, that is there is some significant difference between them. Next find the test statistic. It is equal to x1 bar minus x2 bar divided by square root of, here sample standard deviations are given, that is S1 square divided by N1 plus S2 square divided by N2. Okay, now we substitute the values for x1 bar, x2 bar. x1 bar is 55, x2 bar is 57 and square root of S1 square, that is sample standard deviation of first sample is 10 square divided by N1, that is 400 plus S2 square is 15 square divided by N2, that is 100. On simplifying this equation, we get the answer minus 1.265, that is calculated value of Z is equal to 1.265. Now we choose the tabulated value of Z alpha is equal to 1.96 at 5% level of significance. Now comparing these two values, we get calculated value of Z which is less than the tabulated value of Z alpha, that is 1.265 value is less than 1.96 value. So we conclude that If calculated value is less than the tabulated value means we accept H naught at 5% level of significance. That is, there is no significant difference between the means. X1 is equal to X2. So, accept H naught at 5% level of significance. That is, there is no significant difference between the sample mean. There is no significant difference between the sample means.